Okay, so we are here for Algebra 2, solving equations by square roots and imaginary roots. And you kind of probably saw in the corner there, and kind of flanked, that is Ruja. And Vasya, my other tuxedo cat, he was on the other side of me. He just jumped off the couch. So came home from work, and apparently they're hungry, and so they got to wait through an algebra lesson before they can get their food. Because what's better food for the soul than solving equations by square roots and imaginary roots? So let's dive in. Let's go see what the content is, so that these guys can get some food. So we've already looked at factoring as a way to solve quadratic equations, and I wanted to start off by just reviewing that. It is a critical skill, as I've mentioned, that you know how to solve a quadratic by factoring, and so it's something that I want to just keep coming back to. So we've got an example there. X squared plus 2x minus 8 is equal to 0. I know that that is a quadratic because of the x squared, and it is an equation because of the equal sign. I have over here on the right. Be sure to note the difference between just factoring and using factoring to solve an equation. Okay, so we started off with just factoring. We wanted to master the skill of getting something factored. And then we use that in order to solve equations. Just really pay attention to that, because I have seen plenty of students where the directions say factor and there's no equal sign, and then an equal sign appears. Like the student just puts an equal sign in the problem. Or where there actually is an equal sign there, and then the student factors and stops. So they kind of ignore the fact that there's an equal sign there. So we do want to pay attention to that. Now, our steps for solving an equation by factoring are set it equal to 0, because we're going to be using the zero product property. And so to use the zero product property, we need to have the 0. This one already has a 0, so yay. And then we need a product. Now, right here, I have things being added and subtracted. What I need to get is like something times something else. And the way we do that is by factoring. So I'll set up my parentheses for my factors. Okay, so I know I got parentheses there, and they're equal to 0. And now I need to get it factored. So I'll set it, my area model over here. I've got x squared, I've got -8, and I am looking for two factors of -8 that add up to +2. And so I'll take my 8 over here, and 8 factors into 1 times 8 and 2 times 4. And I can get the 2 that way. I need a +2. So what I'm going to need is a -2x and a +4x. So we'll go ahead and put in the -2x and the +4x. And then this is one of the nice ones, because there's only one way that x squared factors. And so then x times 4 is 4x, and x times -2 is -2x. And then 4 times -2 is -8. You can also make sure you have this right by doing like 1 times -8 is -8. 4 times -2 is -8. So you should get the same thing there. All right, so we have base times the height is equal to that area. And then we engage the zero product property, which says that if we have two things and they are multiplied together, and there's my multiplication, and the product is 0, then at least one of those two things must be equal to 0. You are welcome to jump straight to x equals 2, x equals -4. Okay, that is okay to do. That is what your math teachers do. Okay, when we're solving these, we just go x is 2, x is -4. If you're not comfortable doing that, okay, so if you're like, that seemed like boo, like what happened to different pieces? Okay, here's what we did. We know that either the first factor could be 0, so it could be 0 times the x plus 4, or the 0 could be the other factor. Okay, it could be x minus 2 times 0. Both of those would work, and we do need to catch both of them. And then we go ahead and solve these, and we would solve these by adding 2 to both sides. Therefore, x is equal to 2, or subtracting 4. Therefore, x is equal to -4. And you do need to get both of those answers in order to have solved the equation. And you need both of them because both of those numbers will make the equation true. So we're looking for the value of the variables that will make it true. If you plug a 2 in for x, you will get 0 equals 0. if you plug a -4 in for the x, you will get 0 equals 0. Both of those numbers will work to make the equation true, so you need to have both of them. And that is what we covered a couple lessons ago. Actually, the day that I'm recording this is the day that we covered that in class. So hopefully that's a review, kind of refreshes your memory on what zero product property is and what the process is there. So now we're going to look at another strategy, and this is a strategy that sometimes I'll teach it and sometimes I won't. The two main strategies that we use for solving quadratics are factoring and the quadratic formula. And then there are a handful of others, like there's graphing, which we looked at in the last lesson. There's the strategy we're going to look at now, and then there's another strategy called completing the square. Okay, and those are not as common. It's not that they're not important or valuable, they're just not as commonly used. So this strategy is using square roots, okay? And so the key question we're asking here is, when does this work? One of the reasons this one isn't used a whole lot is because it's very limited in when it works. But when it does work, it's a great strategy to use. So it's one of those things like I don't know, if you're into like cooking or something, you might have a specialty knife that like only is for cutting tomatoes, and it's not super useful all the time because most of the stuff you're cutting are not tomatoes. But when you are cutting tomatoes, this is the tool to have. You want to have it. So it's a little bit like that. So when does this work? This works when your b value is equal to 0, and then I have a clarification there. That is when there is no x term. So you might be wondering, okay, Ms. Taylor, what do you mean by that? Well, I'm glad you asked. So it could be something like this, okay, where you have 2x squared minus 4 equals 0, and you have the x squared and you have the constant, but you don't have that b term, okay? It's just not there. Something like x squared plus 3, okay? Then we could use the square root strategy. So most of the quadratics we look at do have a linear term or a b term or x term in there, okay? But not all of them. And when we don't, this is a good strategy to be able to pull out of your back pocket. All right, it's also going to show us something that's really important with regard to imaginary numbers. All right, so what we're going to do is take this problem, x squared minus 9 equals 0, and we're going to solve it two different ways. Just taking the same problem, we're going to use two different strategies. We should get to the same answer both ways. So the first way that we're going to look at this is through factoring. So I hope that you notice that this is the difference of squares, embedding a little bit of review in here. Okay, difference means subtraction, and the squares mean that both of the things we're subtracting are what are called perfect squares. So this is x squared, which is x squared, don't overthink it, and then 9, which is 3 squared. Okay, and these factor according to a pattern, the a plus b, a minus b. So x plus, and then you think, well, what times itself would give me 9? That would be 3. And then x minus 3. And the vocab word for that is conjugate. Okay, those are called conjugates. Conjugates is like having like a pair of shoes or like a pair of pants or something. They come in pairs, so you don't have like one shoe, or you don't have like a pair of pants with one leg. Okay, that's a little bit weird. Conjugates always come in pairs. So we talk about x plus 3 and x minus 3 are conjugates of each other. Or you could say, what is the conjugate of x plus 3? And the answer would be x minus 3, or vice versa. Once we have it factored, then we can use the zero product property. Now you are welcome at this point to go straight to x equals -3 and x equals +3. But if you would like to do that middle part and really see the zero product property at work, we know that either the left side or the right, or like the x plus 3 or the x minus 3 have to be equal to 0, one or the other. In the first one, we would subtract 3 from both sides, and that's where the x equals -3 comes from. Or we could add 3. Okay, and so our two answers are x equals -3 and x equals +3. All right. Now, I did mention like you're welcome to skip to the end. What some of you might find is that you're sometimes comfortable skipping to the end and other times you're not comfortable. So if the things in the parentheses look like they're going to come out to fractions or something, then you might opt to do the middle step where sometimes you're comfortable skipping it. It's really up to you. The only thing I care about is that you understand the idea at work. How much of the work you write down in this case is not a major issue. So now let's take a look at solving this a different way. So it's the same equation. Now, because there is no linear term or x term, okay, what we're going to do is add the 9 to both sides to get x squared is equal to 9. Okay, now here's where it's easy to mess this up. And this is a little fact that bothered me a lot. I remember my junior year in high school. Like I just had trouble with this. Yeah, not with carrying it out, but just with the idea behind it. So when it is written this way, you've got the x squared. You really have to think about it. What times itself gives me 9? And most of you would say really quickly, that would be 3. So 3 squared is equal to 9. And you're not wrong. Here's the thing. Okay, so 3 squared is equal to 9 because 3 times 3 is equal to 9. But it is also true that -3 times -3 would give you +9. So you've got that negative, and those parentheses are important there. Okay, and so what happens when people will do a problem this way is that they often forget that it is the negative. Now, here's how we would denote it. We would take the x equals 3 and we would put in front of it that little hybrid plus minus. And what that means is x is positive or -3. Like both of those are the answers. And you can see that solving it that way matches the answer that we got through the factoring. This is actually cleaner in terms of the number of steps. Over here, you've got more work going on. This is more likely to catch both answers. This one is a little bit error prone with missing the negative answer. But you can see how they work. And it's the same equation. So we should be getting the same answer. Like the strategy that we're using shouldn't make a big difference or any difference really in what our answer is. Okay. So what about this one? So let's shake it up a little bit. So what about this one? I do want you to note that this is not the difference of squares. So this looks like a lot similar. I came home from work, ran with Marathon High, walked in the door, started recording a video. I'm tired, really tired. So this is not the difference of squares. This is the sum of squares. And there is no formula for this. We could maybe adapt the formula that we use for the difference of squares. I've never seen anybody do that. But this is not the difference of squares. This is the sum of squares. So we can't revert to our formula. Also not going to work really well if we try the area model on this. Because we'd have to, well, you know what? You'll see what happens. But it's actually pretty good for square roots. So let's go ahead and subtract the 9 from both sides. So x squared is equal to -9. Okay. And now we are going to undo this. Okay. So how do you undo squaring? We're going to do square root. And this is the piece that used to bother me in high school. If you have x squared is equal to 9, then the answer is plus or minus 3. But if the problem was written x is equal to the square root of 9, then it was just 3. And because when we take a square root, we assume the positive. And it really, really bothered me because in my head, I thought like that's the same problem. And it's not. It's a bit of a formality, but the square root of x or 9 being 3 and not -3 has to do with like what's called a square root function and how that operation works. So even though you could use a square root to undo squaring, there's like this little hiccup with the signs on the answer. It's not going to be a big deal for you guys. Don't worry about it. Hopefully it doesn't bother you the way it bothered me. It used to really bother me. Okay, so now we're going to have x, okay? X, and we've covered this in the last lesson. So we've got the square root of -9. Well, that is the square root of 9, right? I don't know if you guys can see what just happened on the screen or not. Something weird happened. Square root of 9 times -1. So it's the square root of 9 times the square root of -1. Square root of 9 is 3. Square root of -1 is I. And so it's 3i. Now, here's where that stuff that was going on over here comes into play. The original equation was not the square root equation. It was the one that involved the squaring. And so the plus and minus does come into play. And so the solution to that is plus or minus 3i. Now, because I do, this video I think is going to be pretty short, and I do want to emphasize the consistency of math. You guys know I'm really big about that math is consistent and the ideas stay the same, which is why we focus on the ideas. So if I told you several lessons ago or several times this year that the solution to equation is the value or values of the variable that make the equation true, then that means that if I take 3i or -3i and plug it back into the equation, I should get a true statement. So let's just take a look at that for fun. So we've got like the x squared plus 9 is equal to 0. If I plug in 3i and square it, plus 9 is equal to 0. Well, 3i squared means 3i times 3i. 3 times 3 is 9. I times I is I squared. But I squared is -1. So 3i squared is -9. -9 plus 9 is 0. And 0 equals 0. So I have a true statement. You could do the same thing with the -3i, because -3 times -3 would give you the +9 as well. And then you'd square the I squared. So it still works. It still works, the definition of solution, even if that solution has an imaginary number in it. So the activity that goes with this, and this is, I changed it on your notes. Your notes look different. It says explore outlined on your worksheet. What I want you to do is to solve each of these equations. Okay. And you can pick your strategy, okay, insofar as you can pick the strategy. So this one, we have to use factoring. Number 1, you've got to factor it. Number 3, you've got to factor it. I kept the factoring fairly simple. So you've got that x squared with no leading coefficient. We've got a difference of squares. We have a couple sums of squares, okay? And I want you to practice with that. So practice with the square root technique. Practice with the factoring, okay? Keep getting that practice in. It's only 5 problems. You can do it. After you solve those, then you are going to use Desmos to graph each of the equations, okay? So graph each of the equations, and then this should be on your handout as like 6, 7, and 8 or something. Like I think I just kept numbering them. And I want you to graph each of the equations, and I want you to look for certain things. So let's kind of go over what you're going to look for so that you know when you see it. Which of the equations had x-intercepts or roots or zeros, those are all synonyms, that you could see on the graph? And you're just going to answer like number 1, number 2, and number 4, okay? Or number 3 and number 5, or number 2, 3, and 5, or something. Like which ones were you able to see the x-intercepts? Which equations did not have x-intercepts that you could see on the graph? It should be whatever you didn't pick for number 1. So if you said 1, 2, and 5, then for number 2, you would say 3 and 4. Okay. So either you can see the x-intercepts or you cannot see the x-intercepts. Okay. One or the other. So whatever you didn't pick for 1. Now I want you to look at the answers and try to draw a conclusion matching the answers that you got with what you were able to see on your graph. So based on your answers to the equations, okay, what does getting an imaginary answer mean for what the graph looks like? Okay, so we want to connect the getting that imaginary answer with how that manifests on the graph so that you will know if you are looking at something that has an imaginary answer or not. All right, so that is the whole lesson, as well as a preview of what the homework is, classwork homework. And I did scan this to my email earlier today, so I should be able to upload it to OneNote, at least for the year that I'm recording this. And then you guys, as always, know how to reach out to me with any questions.